this video we will study about the degree of reaction, uh, the phi, which is the flow coefficient. This is the flow coefficient, and this is given by Vx by u. This I, which is the head coefficient, and we will find this for head coefficient, and we find this for an axial flow turbine. Before proceeding, let me draw for you the stages of the turbine. This is the rotor, this is the stator. So the inlet velocity, the stator moves in this direction, and the blades are curved like this. The blades are so much curved that the direction of the flow reverses. So this is u, this is u, this is v1, this is w1, this is u, this is v2, this is v2, sorry, then this and this is w2, u2, v2. u1 and u2 are same, which is equals to u. You can see the direction reversing, right? This is the stator, v3, and for repeating stages v3 equals to v1. So again we will derive and we will check and see if h0r1 equals to h0r2. Let me draw the triangles once again. So this is u, this is v1, this is w1, this is w2, and this is v2. This is beta 1, this is alpha 1. Okay, this is beta 2, this is alpha 2, right? Now we will use the cosine rules. We will have for this triangle, for the inlet triangle, w1 square is equals to u square plus v1, let me write u1 square plus v1 square minus u1 v1 cos alpha 1. v1 cos alpha 1 is vu1. So u1 vu1 is equals to u1 square plus v1 square minus w1 square divided by 2. Okay, I've missed the 2 over here. The next is very important. w2 square for the outlet triangle, outlet velocity triangle, w2 square is equals to u2 square plus v2 square minus twice u2 v2 cos, this is 180 minus this, will take this angle, this is 180 degree minus alpha 2, and cos pi minus theta is minus cos theta. So we have u2 plus v2 square minus plus twice u2 v2 cos alpha 2. v2 cos alpha 2 is this, which is vu2. So this is vu2. So u2 square plus v2 square plus twice u2 v2 vu2 is w2 square. So u2 vu2 is equals to w2 square minus u2 square minus v2 square divided by 2. Okay, and we have h02 minus h, this is very important, h01 because it is a turbine, minus h02 is v. So this is h01 minus h02 is vu1 u1 minus vu2 u2. This is the usual case, but since the direction of v2 reverses, this will be plus. So if we substitute these values over here, we have vu1 u1 is this one, which is u1 square plus v1 square minus w1 square by 2 plus w2 square minus u2 square minus v2 square divided by 2, and h01 is h1 plus v1 square by 2, this is h2 minus v2 square by 2. So if we see that this u1 and this u2 cancels because u1 is equals to u2, because these velocity triangles are drawn at the same level. Let me draw this is the hub. Okay, this is the blade, let's say this is how the blade looks. This is this, so at this cross section, which is the mean blade radius, this is the radius of the root of the blade, this is the tip of the blade. This is also known as the hub radius. Okay, so since we are taking at this radius, and if this rotates as omega, so u is equals to omega into r mean. Okay, so u at this u is same at the entry and the exit. Now v1 square and this v1 square disappears, this v2 square and this v2 square disappears, so h1 plus w1 square by 2 is equals to h2 plus w2 square by 2. Though the derivation is a bit different, but the results are the same. h0r1 equals to h0r2. Okay, now we can write r is equals to h1 minus h1, the enthalpy change at the rotor by enthalpy change in the stage, h1 minus h3. h1 minus h3 we can write as h01 minus v1 square by 2 minus h03 minus and another minus v3 square by 2. Since v1 equals to v3 for repeating stages, this can go, and since stator does not do any work, so h03 can be written as h02. So denominator can be written as h01 minus h02, which is equals to vu2 minus vu1 minus vu2 into u. Okay, and if you see the diagram, vu2 can be written as, again this is plus not minus, right? So vu1 this is vu1, this is vu1 is u plus wu1, u plus wu1 plus vu2 is w, this is wu2 minus u, wu2 minus u into u. This and this goes away, so this is wu1 plus wu2 into u, right? Okay, so this is the denominator, and the numerator is written from here, so this needs a bit more modification. wu2, so w2 square equals to wu2 plus vx square. This is the Pythagoras theorem, because this is a right angle triangle, right? This is vx, the height. So, and w1 square equals to wu1 square plus vx square. So w2 square minus w1 square by 2 equals to wu2 square minus wu1 square by 2. Okay, so r is equals to wu2 square minus wu1 square by 2, and denominator is wu1 plus wu2 to u. Again a square minus b square, we have wu2 square minus wu1 square divided by twice into u, vx by u 1 by 2 wu2 square minus wu1 square, sorry, will be wu2 minus wu1 by vx, which is 1 by half 5 by 2 into cot beta 2 minus cot beta 1. We can see that beta 2 is less than beta 1, so cot beta 1 is less than cot beta 2, so cot beta 2 comes first. R is positive, that's why we can do some modifications. So this is r is 5 by 2 wu2 minus wu1 by vx. wu2 we can write it as this is wu2, this is vu2 plus u, vu2 plus u minus wu1 by vx, 5 by 2, this is 5 by 2, this is 1 by 5 minus wu1 vx minus vu2 by vx. Okay, so this can be written as half minus 5 by 2 cot beta 1 minus cot alpha 2 Okay, so this gives us beta 1 equals to alpha 2 when r is equals to 0.5. We can also write r equals to 5 by 2 into wu2 minus